All right, problem one. We're given this regular octagon and we're asked to determine what fraction of the whole region is shaded. Okay, so the hint I would have for you on this one is to try to break this thing up into congruent shapes. And they don't have to all be the same congruent shape, but so what's a congruent shape? Congruent shapes are shapes that are the same shape and size. So, for example, if I were to draw a line, see if I can draw a line here, across here, assuming that's a straight line that goes from this vertex to this vertex. And if I were to draw a straight line parallel to this line from this vertex ooh, to that vertex, that doesn't look very straight, but okay, then you know that, well, this whole area would be the same as this whole area, as the shaded region. And you'd also be able to see that this triangle formed here is the same as this triangle here. The areas are the same. Because, well, what do we know with a regular octagon? We know that the sides are all the same length, so I could show that by doing this. If I put a double hash mark on each one, each side, all those sides are the same length. Okay? This one and this one. Okay? We know all the sides are the same length, and we know all the angles are the same. And you can determine the angle. Well, you know that the sum of the exterior angles, if you were to draw a straight line parallel or in the same direction as this line, you would know that the sum of this angle and this angle, so let's be this angle and this angle and this angle and this angle and this angle, this angle, this angle, and this angle. Okay, the sum of all those exterior angles has to be 360 degrees. Okay, so we've got 8 of those angles, and we could take 360 divided by 8, and we're going to get 45 degrees. Okay, so each one of these angles has to be 45 degrees. Now, I don't know if that'll help you or not, but actually the most helpful thing is to break this shape into congruent shapes. Okay, so, and if they're congruent if they have the same angles and the same side lengths. So, that is your hint, and I'm going to go ahead and solve this problem now. So what I did to solve this problem is, like I said before, I broke it into congruent shapes. So I'm going to draw another line here. See how straight I can draw it. Oops. Well, let's assume that it goes to that corner. So vertex to vertex. I didn't actually draw it very well there, but so now you can see we've got 4 congruent triangles. I'm going to number them. Actually, I'll start here. 1, 2, 3, 4. And then we've got these rectangles. Okay, because I know it's a rectangle because this is the same. And I know that this has to be 90 degrees. So this is a rectangle. So I'm gonna number these rectangles. 1, 2, 3, 4. Now those rectangles have a different area than the triangle, obviously. And you can also define that there's a square in the middle here, because you can see that if these were parallel lines, obviously this line is not very good. If these were parallel lines, you would see this would have to be a square. The sides are all the same length because they have to be, this side length has to be the same as this side length. So we could actually break this up into some triangles if I draw 2 diagonals here. And you can see that the triangles inside of the square have to be congruent with these triangles on the edges. And why is that? Well, they've got the same, the hypotenuse. Now these have to be 90 degrees, right? So, and also this has to be 90 degrees because these are just diagonals of a square, and they meet at a 90-degree angle and they bisect each other. Okay, so these angles in the middle here all have to be all 90 degrees. Okay, so we've essentially got four 45, 45, 90 degree triangles here in the middle, and these are also 45, 45, 90 degree triangles. And you can see also that the side length of the hypotenuse has to be the same in both cases. So these triangles in the middle of this square are congruent to these triangles out here. So I'm going to continue numbering here. We've got 1, 2, 3, 4. So I'm just going to call this one 5, 6, 7, 8. Okay? So we've got 8 congruent triangles and we have 4 congruent squares. And one way you can look at this is that essentially we've got 2 out of the 8, or 1/4 of all the triangles in the shaded region, and we've also got 1 of the 4 rectangles inside the shaded region. So we've got 1/4 of the triangles and 1/4 of the total number of rectangles. So the area in the shaded region has to be 1/4 of the total. Okay. You can also let's call. I'm going to define a couple of variables. I'm going to call A is the area of the triangles. Okay. That doesn't look like a 45, 45, 90 triangle, but that's what I mean. It's the area of this triangle. So this area is A. This area is A. This area is A. This area is A, and also these areas are all A. You know, they're all the same area. And let's call B the area of the rectangles. Okay? So the area of this would be B, this would be B, this would be B, and this would be B. Okay, so we have, so the total area, well actually let's do the area of the shaded region first, since we want to find the fraction of the total of that. So we have 2 A's and a B is the area of the shaded region. And the area of the whole thing is 8 A's and 4 B's. Okay? And you can see that we could factor a 4 out of the bottom. So we still have 2A plus B on top, and if we factor a 4 out of the bottom, we get 4 times 2A plus B. And of course 2A plus B over 2A plus B, that's just 1, so we get 1/4 that way as well. Alright? So, there's probably other ways that you could do this problem, but the answer is going to be 1/4. Alright.